Hello my fellow working class heroes, good day. I am Carlo and welcome to Carlo Excels. In this episode, we'll talk about item analysis. Specifically, we'll talk about a more specific facet of item analysis, which is multiple choice distractor analysis. In this video, we'll focus less on the calculation and more on the meaning behind multiple choice distractor analysis so that you'll properly understand how to interpret the quality of your test items based on the results of multiple choice distractor analysis. Before anything else, if you're new to this channel, hello, this is Carlo Excels, a channel that is dedicated to teaching my fellow teachers here in the Philippines Microsoft Excel. Occasionally, I also create additional lessons like this that will be helpful to my fellow teachers. Please like this video, share this video with your fellow teachers, and drop a comment down below. It will really help with the YouTube algorithm and help those who are searching for this to find this. Thank you. Oh, and by the way, this is the third video in this channel series on Item Analysis Explained. The previous videos already tackled the Item Difficulty Index and the Item Discrimination Index. If you haven't watched those videos yet, I invite you to watch them first before proceeding with this video. The links to those videos can be found in the descriptions below. Now, we'll talk about multiple choice distractor analysis. The best way to start with this discussion is to first review why we do assessments in the first place. Assessment, in essence, is a tool that we teachers use. In our case, we use this tool to gather evidence of student learning. This evidence is what we can then use to make the proper decisions regarding instructions. In other words, assessment is a means, not an end. After years of being a student and being a teacher, it's very easy to forget and it's very easy to have it the other way around. No, learning is not the means, with the exam and the grade being the end. We should always remember that assessment is the means and learning is the end. Of all the forms of assessment, the multiple choice question is probably the most used. Multiple choice questions are quite popular, especially in today's information age, since this type of test is probably the easiest to codify and automate. Although it's not as easy to make as simple identification questions or essay questions, multiple choice tests are very easy to understand, quick to administer, and can be used for a variety of purposes, from educational testing to research to national elections. The basic multiple choice question has three parts. We have the stem, the key, and the distractors. The stem is the question to be asked, or the incomplete statement to be completed. To answer the question asked by the stem, the student must pick from a limited number of alternatives. Out of these alternatives, the correct answer is what we call the key. For the student to prove that he or she truly knows the answer to the question asked by the stem, the student needs to pick out the key from the other alternatives, which are wrong answers. These alternatives that are wrong answers are what we call distractors. For a multiple choice question to be considered good and valid, all of its parts must work correctly. The stem must ask a solid, clear, unambiguous, and unequivocal question. To a student who knows the subject material being tested, the key must appear as the definite correct answer. To a student who does not know the subject material being tested, the distractors must appear as possible correct answers. And this is what multiple choice distractor analysis is for. Multiple choice distractor analysis allows the teacher to study the effectiveness of the different parts of the multiple choice question by analyzing the frequency of student choices on the different alternatives of the multiple choice question. The first step in multiple choice distractor analysis is to separate the students into high groups and low groups. So first, you check the test and then get the results of the students and then arrange the students by their results on the test from highest score to lowest score. If you line up the results of the test, meaning the total scores of the students in a straight line arranged from highest scores to lowest scores, you will easily see the spectrum of students' ability or understanding as far as the whole test is concerned. Naturally, on one extreme side of the line, you may have students with high scores on the test. It may be safe to assume that these are the students who have studied for this test and know the subject material that this test is measuring. And on the other extreme side of the line, you have students with low scores on the test. It may be safe to assume that these are the students who have not studied for this test and have not absorbed the subject material that this test is measuring. The problem is the middle part of the line. In the middle part of the line, you have students that may actually know the subject material and have studied, but maybe they just have poor test-taking skills or poor comprehension, so even if they know the answers, they still got the questions wrong. In the middle part of the line, you may also have students that actually do not know the subject material or have not studied, but maybe they just have very good test-taking skills, or they're good at eliminating choices from multiple choice items, or they have good comprehension skills, so that even if they don't know the answers, they still got the questions correct. That is why, in the standard practice of multiple choice distractor analysis, we remove the middle part to remove uncertainties. We only assess the extremes. We take just the students with the highest scores, which we'll call the high group, and the students with the lowest scores, which we'll call the low group. We'll then assess just them. That way, when we assess the difficulty of our items, we can assess it based on knowledge of the subject material and not based on comprehension or test-taking skills. Okay, how many students should be in the high group and how many students should be in the low group? The standard practice is 27% of the total number of students who took the test. The high group shall be the highest scoring 27% and the low group shall be the lowest scoring 27%. Also, please make sure that both groups have an equal number of students. What we do next is this. For every multiple choice question we have, we count the number of instances each alternative was chosen by members of the high group, and we do the same for the number of instances each alternative was chosen by members of the low group. Then we compare the figures and analyze the implications. Consider the example on the screen right now. Let's say that we have 100 students who took the exam. 27% of 100 is, of course, 27, so that we have 27 students in the high group and 27 students in the low group. Next, consider this illustration on the screen right now. Let's say that on this particular test item, we have a question with 1 key and 3 distractors. As you can see on the screen, all 27 students in the high group answered the key, and all 27 students in the low group answered the distractors in equal amounts. A situation like this is considered to be the most ideal. If the question is written correctly, then all of the students in the high group, meaning the students who showed up to class, did their duties, and studied their lessons, should be able to interpret the multiple choice stem properly, and they should be able to properly pick out the key from the distractors. And again, if the question is written correctly, then all of the students in the low group, meaning the students who have not properly absorbed the lessons, should get properly misled by the distractors. Because they don't know the subject material, the distractors should look like the correct answer to them, and therefore, they would answer the distractors and not the key. For this particular situation, the test item can be considered to be perfectly moderate in terms of item difficulty analysis, perfectly discriminating in terms of item discrimination analysis, and optimal in terms of multiple choice distractor analysis. This situation you see on the screen right now is what we should aspire to for all of our multiple choice test questions. Next, consider this illustration on the screen right now. Let's say that on this particular test item, we have a question with 1 key and 3 distractors. As you can see on the screen, some students in both the high group and the low group answered the key. Some students from both the high group and the low group answered the various distractors. However, please notice that the high group answered the key much more frequently than the low group. Also, please notice that the low group answered the distractors much more frequently than the high group. This situation is not perfect, but it can still be considered a good question with good distractors. There are more students in the high group than students in the low group that answered the key. This indicates that the key is doing its job properly in appearing as the correct answer for students who studied and learned the subject material. There are more students in the low group than students in the high group that answered the distractors. This indicates that the distractors are doing their job properly in appearing as the correct answer for students who did not learn the subject material properly. Again, this situation is not perfect, but it can still be considered a good question with good distractors. Next, consider this illustration on the screen right now. Let's say that on this particular test item, we have a question with 1 key and 3 distractors. And as you can see on the screen, some students in both the high group and the low group answer the key. Some students from both the high group and the low group answer the various distractors. However, please notice that the high group answered the key much more frequently than the low group. Also, one of the distractors was answered by the low group more frequently than the high group. Once again, as discussed in the previous example, as far as the key and that one distractor is concerned, those are fine. This indicates that the key is doing its job properly in appearing as the correct answer for students who studied and learned the subject material. That one distractor is doing its job properly in appearing as the correct answer for students who did not learn the subject material properly. However, please direct your attention to that one distractor that has an equal number of students from both the high group and low group that answered it. In other words, both students who learned the subject material and students who did not learn the subject material picked this distractor. So, does it do its job properly in appearing as the correct answer? In a situation like this, it depends on your standards you wish to set for yourself or your test. Some authors and professors would consider this as a bad distractor already and will advise you to change it. I agree, however, with some other authors and professors who would consider this as an okay distractor since it is still doing its job of appearing as the correct answer to the students in the low group, even if it did fool a number of students in the high group too. So again, it'll depend on your judgment as a teacher, your own standards, the standards of your school, and the judgment of the authors and professors you choose to listen to. Now, please direct your attention to that other distractor that has zeros in it. Nobody from both the high group or low group answered it. This is called a rejected distractor. Remember that the job of a distractor is to distract. Its job is to fool students who have not learned the subject material by appearing as the correct answer. But in this situation, this distractor has not fooled anyone. It appears as an obviously wrong answer to everyone, so it's not doing its job to distract. And so, if in case this test question is to be used again in a future test, this distractor must be replaced by something else. So, as a whole, is this multiple choice question a good question? Although it is not perfect, it can still be considered a good question. If you conduct an item discrimination analysis on this, it'll still be discriminating, and 2 of the 3 distractors are still working just fine. However, if you choose to use this question again in a future test, just remember to replace that one distractor that is useless. Next, consider this illustration on the screen right now. Let's say that on this particular test item, we have a question with 1 key and 3 distractors. As you can see on the screen, some students in both the high group and the low group answered the key. Some students from both the high group and the low group answered the various distractors. However, please notice that there is an equal number of students from both the high group and low group that answered the key. In a situation like this, there may be a problem with the stem or the key if both students from the high group and the low group can answer the question correctly. Think about it. A student who does not study and has not learned the lesson can still answer the question with an equal chance to somebody who actually studies and has actually learned the lesson. That shouldn't happen. If you run this item through item discrimination analysis, this item will definitely turn out as not discriminating. Next, please note that on one of the distractors, there are actually more students in the high group that answered it compared to students in the low group. Now, think carefully about how strange this situation is. For the high group, meaning the students who studied and students who have learned the subject material, this distractor looked like the correct answer to them. And to the low group, meaning the students who did not study and have not learned the subject material, were not fooled by this distractor. Not only is something potentially wrong with the question, but something is also potentially wrong with this distractor. As a whole, according to the results of multiple choice distractor analysis, this question should either be revised completely or should never be used again in any future test. Next, consider this illustration on the screen right now. Let's say that on this particular test item, we have a question with 1 key and 3 distractors. If you've been following our discussion so far, you can see that this is the absolute worst that a multiple choice test question can be. The students in the low group, meaning the students who did not study and have not learned the subject material, are the ones that got the question right. And the students in the high group, meaning the students who studied and the students who have learned the subject material, were the ones that were fooled by the distractors. The discrimination index of this question is perfectly horrible. So if you did your job in teaching the students the subject material and you administered a test in good faith, you'll probably never encounter a situation like this. And if you do, I'd think that this was probably a trick question. So again, this is merely an illustration of the absolute worst result that multiple choice distractor analysis can have. Now, I know that some people may have this question in their minds already. After learning the difference between good distractors and bad distractors, how many distractors do we really need? The rule is, you need at least 2 good distractors. I'd like to emphasize the word good. You need at least 2 good distractors. It doesn't matter if you have 20 distractors but 19 of them don't work correctly. 2 good distractors will be just fine. But please note that if you choose to write a question with 3 distractors, all of them have to be good. If you choose to write a question with 4 distractors, all of them have to be good. please don't include distractors that cannot possibly be considered as the correct answer just for the heck of it. Okay, now that we've properly seen the different possible results that you may have when analyzing your multiple choice items, we then have to ask the question, why does this happen? What are the major causes for multiple choice distractor analysis to have good or bad results? If you've watched the previous video on this series, the video on the discussion of the Item Discrimination Index, then this list on the screen right now may be familiar to you. If you haven't watched that video yet, once again, the link to that video is in the descriptions below. In that video, I outlined possible causes for why an item can have a result of not discriminating. Please note that all of these can also be possible causes for why you may have bad results in your multiple choice distractor analysis. Out of all of these possible causes, I'd like to highlight the third item. Once again, the most common reason why you may have bad results in your multiple choice distractor analysis is your test's answer key is wrong. Yes, this is the most common reason why your multiple choice distractor analysis may have bad distractors. So when it does, your first instinct should be to check the item's answer key because errors in answer keys most commonly happen with multiple choice questions. Errors in the answer key include the possibility that a distractor is legitimately a possible correct answer to your given question. If the students in the high group are choosing a distractor instead of the key, check the question again. Think about how the question is written or how the distractor is written because maybe the students in the high group are right. Maybe the distractor is, in fact, a possible alternative correct answer to your question. Now, it's time to talk about the formula and the calculation process to determine the effectivity of our multiple choice question distractors. But before we go there, some of you may be asking, why do we need to calculate the effectivity of our multiple choice question distractors? Why can't we do it the mathless way? Why can't we just continue simply counting the number of students who answered each alternative and then compare the answers of the high group and the low group? There are actually many advantages when calculating the effectiveness of multiple choice question distractors. By getting the effectivity values, it'll be much easier for us to compare distractors. It'll be easier for us to determine which distractor is more effective or less effective compared to others. This channel has an all-in-one item analysis template that helps by calculating the internal consistency, item difficulty index, item discrimination index, and multiple choice distractor analysis. If you're interested in this free, easy-to-use tool, please check the descriptions down below where you will find a link to the video that talks about the Carlo Excels all-in-one item analysis template. Also, in that video link, you'll find the item analysis template available for download, absolutely free, no strings attached. The formula for the effectiveness of multiple choice question distractors can be seen on the screen right now. What we are essentially doing is getting the discrimination index of each and every distractor of the multiple choice question. The formula is the number of students in the high group that picked the alternative minus the number of students in the low group that picked the alternative, which will be divided by the number of students in one of the groups. The result of this calculation is the item discrimination index of each distractor, a number between -1 and 1. And again, this calculation is done for each and every distractor for each multiple choice question on the test. So some of you may be wondering, wait, do we do this only for alternatives that are distractors? Do we not do this for the key? No, we don't. Please note that the key is analyzed separately because the proper way to assess the key is not through multiple choice distractor analysis but rather through item discrimination index. So for our distractors, once you've made all the calculations, again, you'll get a number between -1 and 1. A positive number result indicates that more high group students than low group students picked the distractor, and it's therefore a bad distractor. A negative number indicates that more low group students than high group students picked the distractor, and it's therefore a good distractor. The closer the result is to -1, the better the distractor is at doing its job. The closer the result is to 1, the worse the distractor is at doing its job. If the result is 0, you have to check, is it 0 because there is an equal number of high group students and low group students who picked it? Or is it 0 because nobody picked it? If the result is 0 because there is an equal number of high group students and low group students that picked the distractor, then that can still be considered as a good distractor. If the result is 0 because nobody from both the high group and low group picked the distractor, then it is a rejected distractor. Consider the illustration on the screen right now. Because there are 100 students who took this sample test, there are 27 students in the high group and 27 students in the low group. This particular multiple choice question has A as its key and it has 4 distractors. For the high group, 13 students answered A, which is the key, no student answered B, 8 students answered C, 4 students answered D, and 2 students answered E. For the low group, 11 students answered A, which is the key, no student answered B, 4 students answered C, 10 students answered D, and 2 students answered E. At this point, you may pause the video if you wish to do the calculation yourself. So, once again, because A is the answer, A is the key, we won't perform any multiple choice distractor analysis calculation on it. But just by looking at it, because more students in the high group than students in the low group answered the key, then we already know that this multiple choice question is discriminating. For distractor B, after applying the formula, the result is 0. Because nobody picked this distractor is a rejected distractor. For distractor C, after applying the formula, the result is positive 0.1481. Because the result is a positive number, this distractor is a bad distractor. For distractor D, after applying the formula, the result is negative 0.2222. Because the result is a negative number, this distractor is a good distractor. For distractor E, after applying the formula, the result is 0. However, it became 0 because there is an equal number of students from the high group and low group who chose this distractor. Therefore, we can still consider this a good distractor. So, as we are about to end our discussion on multiple choice distractor analysis, let me state that the next lesson will feature reliability. So please subscribe to the channel so you don't miss that lesson when it comes. So that's it for this lesson on multiple choice distractor analysis. I really hope I earned your subscription today. Once again, I am Carlo and this is Carlo Excels. Thank you very much for watching.